Hello everybody, welcome back. Today we're going to talk a little bit about the idea of refraction, or the bending of light as it changes speed. Remember when we first started this lesson, we said that there are three ways that you can change the direction of a light photon. You can reflect it, in other words bounce it off of something. You can refract it, which means change its direction as you change the speed of it, or you can diffract it. For refraction, I find that it helps to have a mental model of what's going on. Since we can't see individual photons, it helps to picture something a little bit larger, which we have seen. So here I've got a picture. Pretend this is an overhead view. The gray rectangle is just it's pavement. It's a parking lot. The brown rectangle is mud. And on this pavement, we've got a four-wheel drive truck. So we're overhead looking down like we're in a helicopter or something, and we can see through the truck and we can see its tires. And that truck is going to be driving from the pavement into the mud. Here's the path that it will be following, and we'll go on ahead and put in a normal, because remember when we talk about directions, the normal is always the thing that we compare to. Now as the truck drives into the mud, I want you to pay attention to this tire right here, because that's the tire that's going to hit the mud first. When that tire hits the mud, it's going to kind of bog down and lose traction. The other three tires, since they're on the pavement, will keep spinning. They'll still have traction. And the result is the truck is going to veer to its left. So when it drives into the mud, it's going to be like this. It turns a little bit, then continues moving on. So the path of the truck would be like this. The blue ray, or the incident ray, is the direction it was traveling before it hit the boundary. The red ray is the refracted ray, or the direction it was traveling after it passed through the boundary. This angle between the indigo and the normal is the angle of incidence. The angle between the red ray and the normal is the angle of refraction. And notice that angle 1 is bigger than angle 2. So anytime something is going from one medium into another and it slows down, it always bends toward the normal. Light will do that as well. When light is traveling in a vacuum, there's nothing for it to interact with, and it travels at its maximum speed. If light travels into some transparent material, though, like air or glass or water, something of that sort, then it has to interact with atoms as it passes through it. And that interaction always takes a little bit of time. So as a result, light travels slower in all those things than it does when it's in a vacuum. And in fact, it travels at a different speed in glass than it does in water, and a different speed in water than it does in air, and so on. But anytime it's traveling from one medium to another and it slows down, it will always bend toward the normal. Now, let's take this the other direction. Let's think about what would happen if it was moving from the mud, or the truck was moving from the mud onto the pavement. So here's our truck again. This time it's in the mud to start with, and it's going to be heading toward the pavement, and it's going to strike the boundary at this angle. So we've got our normal, so we can have something to compare to. Now, if we stop and think about this, which tire is going to hit the pavement first? Well, it's going to be this front left tire. And when that front left tire hits the pavement, it's going to get traction because it'll now be on pavement. The others will still be in mud. So it's going to speed up before the rest of them do. And when that happens, the truck is going to follow a path like this. It'll bend and turn a little bit because that front left tire got traction first. And so the path will now look like this. Again, the indigo ray represents the incident ray. The red ray represents the refracted ray. And we can see that when that truck was speeding up, it bent away from the normal. Light does the same thing. When light travels from one medium into another, and it travels into something that allows it to travel faster, it will always refract away from the normal. So, in a later unit, we'll discuss how we can mathematically describe this, and we'll do that using Snell's law. We'll see you then.